Hello my dear students, welcome to IMS Gate Academy Gate PYQ series of communication system subject. So in the earlier sessions we started from the year 2023 and then 2022 like that up to 2017. We have discussed the selected questions which are asked in the previous years, right? So in this particular session we are going to discuss the selected questions which are asked in the year 2016, right? So in the last class, if you remember, I have given one homework question. So how many of you tried that question? And whoever getting the answer, at least you can mention the chart now. Okay. So all of you kindly mention what is the answer you got for the last question which I have given as a homework in the previous session. Okay. So if you want, I will show the question once again. And whoever couldn't solve earlier, no problem at all. At least I will give some time for you all now. So all of you can give a try and you can mention the answer in the chart, right? After that, we will discuss the selected questions which are asked in the year 2016. Okay, in the 2016 year, we are having multiple sets in EC branch. So in this particular session, I am going to discuss the very interesting questions which are asked in the chapter Information Theory, right? So this is the question asked in the year 2017. This is a question I have given as a homework earlier. So all of you give a try. Whoever tried earlier, you can mention your answer in the chart. Okay, whoever couldn't solve this question earlier, no problem at all. I am going to give once again time for you. You can mention your answer in the chart. Yeah. So if you read this question carefully, you can easily answer this question without using pen and paper. That much simple question and dead easy question, right? So first let us read the question. Here they have mentioned x1, x2, both are independent random variables. Okay. Regarding x1, they have given the mean value as 0 and variance as 1. Similarly, regarding x2, they have given mean value 1 and variance 4. And now the question is, the mutual information I of x1 comma x2 between x1 and x2 they are asking, right? So here the question is regarding mutual information, right? And regarding the random variables x1, x2, they have mentioned it is independent. See the contradictory here. Whenever they are asking mutual information, that means you will get something as the answer provided if x1, x2 are dependent, right? But here x1, x2 are independent. Now the mutual information value is how much? Obviously 0, right? Because x1, x2 are independent, right? So directly you can mention the answer for this question as 0. I of x1 comma x2 is equal to 0 since x1 and x2 are independent random variables. Since x1 and x2 are independent random variables. Okay, actually whatever the data they have given regarding mean and variance, that is not at all required. Okay, but just to make the question somewhat lengthy or sometime in order to make you confusion, right? So they have given the other data. So whenever you are solving any question, definitely most of the data will be useful for solving that question, but sometime few data, okay, some data they will give additionally, but that may not require for solving that question, right? Okay. So that time don't get any confusion at all. Okay, if you are fundamentally strong, you can easily answer the question, and in fact you can answer the question correctly, right? Okay, now let us solve the questions which are asked in the year 2016, right? Okay, so this is the question asked in GATE EC in the year 2016, set 2 for 1 mark. Okay, all of you give a try. I will give some time for every question. All of you can try, and whatever the answer you are getting for every question, after solving it, you can mention the chart. After that, I will explain the question, so that even suppose due to any reason if you got wrong answer, no issue at all. Okay, you can correct where you had done the mistake later, right? Yeah, time up. Whatever the answer you are getting, you can mention the chart. So first let us read the question. Here in this particular question they have mentioned you are having a discrete memoryless source and which has an alphabet. Alphabet means it is going to produce some symbols. Okay, the set of symbols here they are calling it as alphabet. Here you are having A1, A2, A3, A4. Those are the 4 symbols that particular source is going to produce. And for each symbol they have mentioned the corresponding probability. Corresponding probability as like for A1 the probability is 1 by 2. For A2 the probability is 1 by 4. Similarly for A3 and A4 the probability is 1 by 8. 1 by 8. Now the question is the minimum required average code word length. They are asking minimum how much average code word length that we require so that thus here we will get error-free reconstruction. This is a very important sentence in this entire question. Okay, so in order to get error-free reconstruction, how much bits we have to consider? What is the minimum length of the code word that we have to consider? Okay, so whoever knows regarding this, the minimum average code word length required, whoever knows regarding this one, what is the formula or relation, they only can solve this question. Otherwise most of the students can skip this question. Okay, they cannot answer this question because they haven't mentioned another keyword. If they could have mentioned another keyword, then definitely most of the students can easily answer this question. But in this question, instead of asking regularly, they have asked just for variety, they have made some twist in the question. Okay, so the minimum required average code word length is nothing but any guess? At least you can guess now. So they are asking minimum code word length, that is nothing but entropy. Entropy is nothing but what? Average information, right? Suppose if you are considering whatever the entropy you are getting, how many bits you are going to represent for every symbol, if you are considering that is the minimum length, right? So if you are considering that one, okay, regarding the code word length, so that means there won't be any error. Okay, more than entropy, any number you can consider regarding the code word length, no error at all. But in this question they are asking the minimum code word length. So L minimum is nothing but entropy. L minimum is nothing but entropy. Okay, so I hope all of you know the formula regarding entropy, right? So probability into log 1 by probability. So here summation over I equal to 1 to n, probability into log 1 by probability. Can you guess what is the base of this logarithm? All of you please respond. So for the time being I am writing 1 by p as p power minus 1, that minus 1 will come here. Okay, otherwise you can keep like this, no problem. Okay, when you are writing like 1 by p as p power minus 1, that time you will get minus, this entire formula will remain same, summation over I equal to 1 to n pa into log pa. What is the base of this logarithm? Base is 2. Yes, very good, base is 2. Okay, so in this question we are having 4 symbols and for every symbol they have given the probability. Okay, so just substitute here. So first symbol probability is 1 by 2. 1 by 2 log 1 by 1 by 2 is nothing but 2. I am directly writing the direct step. Okay, 1 by 1 by 2 is nothing but 2, base 2, plus second symbol probability is 1 by 4. Second symbol probability is 1 by 4 log 1 by 1 by 4 is nothing but 4, base 2. Similarly third symbol probability 1 by 8 log 1 by 1 by 8 is nothing but 8, base 2. Similarly fourth symbol also same term you are going to get because probability is same, 1 by 8 only, right? 1 by 8 log 8 base 2. 1 by 8 log 8 base 2. Okay, so just observe here they have given probabilities 1 by 2, 1 by 4, 1 by 8, 1 by 8. Okay, right. Log 2 base 2 is nothing but 1. Log 2 base 2 is nothing but 1. So you are getting 1 by 2 plus. log 4 base 2, you can write it as 4, you can write it as 2 square. 4 you can write as 2 square. Similarly, whatever this term here you're having, same term you're having, so that means you can consider this term and multiply with 2, right? This overall term summation is nothing but multiply this term with 2. Okay. Say for example, if you are considering this is x plus x is what? 2x. So 2 into 1 by 8 into log 8, we can write it as 2 power 3. 8 we can write as 2 power 3. Now 1 by 2 you can copy as it is. Now this power 2 will come here, right? So that means you are going to get 2 by 4. Log 2 base 2 is 1. Log 2 base 2 is 1. Similarly here 2 4 times, and this power 3 will come here. Okay, then log 2 base 2 is nothing but 1. So that means you are going to get here 3 by 4. 3 by 4. So here 2 by 4 is nothing but 1 by 2. 1 by 2. So 1 by 2 plus 1 by 2 is nothing but 1 plus 3 by 4 you can write as 0.75. So that means you are going to get 1.75 bits. 1.75 bits. In general, the entropy units are bits per symbol. Okay. Regarding the code word length, so always they will represent in terms of bits. That's why here with respect to the term, accordingly we have to represent. Of course, whatever you are getting the information ultimately for the symbols only, because here if you observe you are having discrete memoryless source, it is going to produce various symbols, right? So how many bits on an average, you are going to represent for every symbol? That is nothing but 1.75, which is nothing but your entropy. So here minimum code word length required is nothing but same as that of entropy. The final answer for this question is 1.75. 1.75. I hope it is clear for everyone. Now I will show the next question, which is asked in GATE EC 2016 in set 1 for 2 marks. Set 1 for 2 marks. All of you give a try. For solving this question, whatever the entropy formula we have used in the earlier question, you can use that one. And if you are good at some infinite series which you have learned in the mathematics subject, so whoever having the knowledge of that infinite series concept, they only can answer this question, right? So all of you give a try. So whatever the answer you are getting, you can mention in the chart meanwhile. Okay. So this is a very interesting question which is asked in GATE EC 2016. If you want, you can put 5-star rating for this question. See the difference between the previous question and this question. In the previous question, they have given only 4 symbols and they have given the corresponding 4 probabilities. Whereas here, this particular source is going to produce infinite symbols like this. Okay. And the corresponding probabilities order they have given like this: 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32, like that. That means what is happening? The next symbol probability is getting half of the earlier probability, right? Half of the probability of the earlier symbol, right? So now they are asking entropy of the source. Entropy of the source. The previous question, this question, more or less we are calculating entropy only, but in the earlier question you are having only 4 symbols, but here you are having infinite possible symbols. That is the only difference. Okay, right. So regarding entropy, you know the formula. Entropy equal to summation over I equal to 1 to n probability into log 1 by probability base 2. Base 2. So here first symbol probability they have given 1 by 2. 1 by 2 log 1 by 2 is nothing but 2. Log 2 base 2 plus next symbol probability is 1 by 4. Here you will get log 4 base 2. Similarly, next symbol probability is 1 by 8. Log 8 base 2. Similarly, next one 1 by 16 is the probability. 1 by 16 log 16 base 2. Similarly, next symbol probability they have given 1 by 32. Log 32 base 2. And so on. This series is continuing up to infinite. So here 1 by 2 log 2 base 2 is nothing but 1 plus 1 by 4. This term you can write it as log 2 square base 2. 2 square base 2 plus 1 by 8. This term you can write it as, can you guess? Yes, you have to write whatever here you are having the terms, you are writing in powers of 2 because here base value is 2. Log 2 power 3 base 2. Similarly here 1 by 16, this 16 you can write as 2 power 4. Log 2 power 4 base 2. Similarly 1 by 32. Now can you tell 32 how we can write in powers of 2? Yes, very good. 2 power 5, right? 2 power 5 is nothing but 32. So like that this series is continuing up to infinite. Okay. So 1 by 2 plus, here this 2 will come here, right? 2 by 4 plus this 3 will come here, 3 by 8. Similarly this 4 will come here, divide by 16 plus this 5 will come here, 5 divided by 32. And the series is continuing up to infinite. Okay, right. So here 2 times, here 4 times. Okay, right. So from this entire series, I am taking 1 by 2 as common. Then here you will get 1 plus. Here also 1 by 2 only, so that means the same term you are going to get. Okay. So since 1 by 2 you have taken, here also you are going to get 1 only. Next. Here numerator 3 I am keeping as it is. Denominator I have taken 2 as common. So here you are going to get 4. 2 4s are nothing but 8. Next. Here numerator you are having 1, you can keep as it is. In the denominator you are having 4. Out of 4 I have taken 2 as common. So that means you are going to have 2. 2 2s are 4. Similarly here 5 is in the numerator, you can keep as it is. 2 I have taken common from the denominator. So here you are going to have 16. 2 16s are nothing but 32. Now this series is continuing up to infinite. Right. Now if you carefully observe, whenever you're having infinite series, you will get some fashion, right? So try to arrange that particular infinite series in the standard form so that you can represent the overall equation into simplified form, right? So for the timing, if you observe, 1 by 2 we can keep as it is, and this 1 also as it is. Now this one I will modify. I will modify as 2 into 1 by 2. 2 will get cancelled. Ultimately you are getting 1 only, right? Hi Patel. Which step you are having doubt? Is it clear up to this step? 1, 2, 3. Whether third step is clear? Yes Patel, your chart is visible. So I am asking whether third step is clear or do you have any doubt? Yeah, third step I will explain. See here, we have used the entropy formula. Yes, okay, I will repeat. Entropy formula, you are having probability into log 1 by probability. Okay. So in the given question, they have given probabilities like 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32 like that, right? So what are the probabilities they have given? We have just substituted in this particular term. Like that, since 5 probabilities they have given, we have written 5 terms, and like that the series is going up to infinite. Okay, right. So here log 2 base 2. Log 2 base 2 is nothing but 1. Log 2 base 2 is nothing but 1. So 1 by 2 into 1 is nothing but 1 by 2. Here you are having base value for all the logarithms, you are having base value 2. So whatever you are having, these values like 4, 8, 16, 32, all these values we are representing in powers of 2. I hope you know that 4 is nothing but 2 square, 8 is nothing but 2 power 3, 16 is nothing but 2 power 4, and 32 is nothing but 2 power 5. Okay, right. Here 4 I have written as 2 square. 1 by 4 I have kept as it is. This 4 I have written as 2 square. Similarly, 1 by 8 as it is. 8 I have written as 2 power 3. Similarly, 16 I have written as 2 power 4. 32 I have written as 2 power 5. I hope it is clear now. Okay. So when you are having the formula like this, say for example log x power m base n. So this one you can write it as m log x base n. I hope you might have studied this formula in your regular mathematics, right? Yeah. Yes, very good Patel, very good. So according to that one, this 2 will come here. Similarly, 3 will come here. Similarly, this 4 will come here. Similarly, 5 will come, right? Yes, very good. So after that, we have just done the simplification. Wherever calculation possible, we have done the simplification. After that, from this entire series, I have taken 1 by 2 as common. 1 by 2 as common. So that time you are getting 1 plus 3 by 4 like this you are getting. Okay. But when you look at this series, it is not coming in the standard form. Okay. Now in order to get the standard form, I am just doing some slight modification so that this entire infinite series we can write into the simplified form. Okay. So for that, what I have done, this 1 I have kept as it is. Now here you are having 1, I have written like 2 into 1 by 2. 2 into 1 by 2. Now here 3 you can keep as it is. Into 1 by 4 you can write as 1 by 2 whole square. 1 by 2 whole square, right? Okay. Next. Now if you observe carefully, 1 plus 2 times x plus 3 times x square. Now here actually you are having 1 by 2, but I am just representing like this. 2 into x plus 3 into x square, like that 4 into x cube. Whether this overall term is going to get 1 by 2 or not, let us see. 1 by 2 whole cube is nothing but 1 by 8. 4 into 1 by 8 is nothing but, yes, we are getting 1 by 2. Next. Now can you tell, Patel, can you tell 5 by 16 how we can write? 5 by 16 how we can write? Any guess? 5 into, now tell me. Like this the series is continuing up to infinite. 5 into 1 by 16 you are having, right? 1 by 16 we can write as 1 by 2 whole power 4. 1 by 2 whole power 4. Okay, I hope it is clear how I have written this series into this particular format. Okay, now you can observe, okay, this 1 by 2 is like for overall term you are getting like multiplying factor. Okay, just observe this bracketed terms like 1 plus 2 times x plus 3 times x square plus 4 times x cube plus 5 times x power 4. Like that the series is continuing up to infinite. So can you recall this particular infinite series we can represent into what format? You might have studied in the mathematics, right? So can you recall how we can write this entire expression into the simplified form? So whatever the format you got, I am just representing here. 1 plus 2 times x plus 3 times x square plus 4 times x cube plus 5 times x power 4. Like that the series is continuing up to infinite. 1 plus 2x plus 3x square plus 4x cube plus 5x power 4 and so on. This entire expression we can write it as 1 minus x whole power minus 2. If you know this formula, then only you can solve this question. Otherwise, even though you know the formula of entropy, you cannot answer this question because here you are getting infinite series, right? So you can remember this formula, 1 minus x whole power minus 2. Now by using this one, whatever the equation here you got regarding entropy, that one we can simply represent as, here 1 by 2 is the multiplying factor, so you can keep as it is. Now this overall expression, now we are going to represent in this particular simplified format. Here you are getting 1 minus x. X is nothing but, here you are having 1 by 2. X is nothing but 1 by 2. 1 by 2 whole power minus 2. Whole power minus 2, right? So 1 by 2 I am keeping as it is. 1 minus half is nothing but 1 by 2 whole power minus 2. This 1 by 2 we can write it as 2 power minus 1. See, 2 is in the denominator, I have brought to the numerator, then the power will become negative, similarly vice versa. Okay, so 2 power minus 1 whole power minus 2. I hope all of you know this formula, like a power m whole power n. A power m whole power n is nothing but a power mn. So by using this relation, you can write this one as, can you guess, Patel, what is the term you are going to get regarding this particular expression? 2 power minus 1 whole power minus 2. Meanwhile, I will write this 1 by 2 as it is. By using that formula, what is the overall expression you are going to get? See, just you have to multiply these two powers, that's all, right? Minus into minus plus, 1 into 2 is nothing but 2. So that means you are getting 2 square. So 2 square is nothing but 4 divided by 2, which is nothing but 2. So here units are bits per symbol because they have mentioned entropy. Entropy units are bits per symbol. On an average, for every symbol, how many bits we are going to represent? For this question, the answer is 2. Even though it is infinite series, infinite number of symbols that particular source is going to produce, but still we are able to calculate the entropy with the help of the standard formula, right? So in this way, whatever the infinite series equations or formulas you are having in your mathematics, try to recall once, so that whenever they are framing such kind of questions here in the information theory sub chapter, right? So definitely you can solve these questions. But if you don't know those infinite series formulas, even though if you know the formula of entropy, so that means with the help of partial knowledge, you cannot solve the questions in the GATE exam, right? So that is the reason, in general, some questions they will ask related to one subject only, and sometimes they will ask the questions based on two different chapters of the same subject, and similarly in some questions they will frame the concepts of two different subjects as well, right? So whenever if you want to attempt the questions related to the advanced subjects, definitely you should be strong on the basic subjects. Once if you are strong on the basic subjects, then no matter whatever may be the level of the question they may ask in the GATE exam related to any subject, okay, you can answer the question. In fact, you can attempt the question correctly, right? Provided if you are fundamentally strong. So try to recall the basics whenever you get time, okay? So don't forget whatever the formulas you might have studied in the mathematics subject, don't forget. Try to recall or just practice good number of questions so that you can remember the formulas. You will get the familiarity about the formulas, okay? So don't by heart any formula. If you want to remember any formula, if you are doing by heart, you may remember temporarily, but you may not remember for long run, right? So if you want to remember for long run, just try to practice good number of questions so that while you are practicing the questions, you are applying the formula. So that means you are able to recall the formula, and when you are substituting the values, you are getting the familiarity about the formula. In that way, you can remember the formula for long run, right? Okay. So next question, all of you give a try. All of you give a try. Yeah, time up. Whatever the answer you are getting, you can mention the chart. So just read the question carefully. Here they have mentioned an analog baseband signal which is band limited to 100 Hz. So regarding band limited, the term I hope all of you are familiar. Band limited is nothing but which is having very low frequency and starting frequency is 0 Hz onwards. Okay, right? And here they have mentioned the maximum frequency of that particular signal is 100 Hz. 100 Hz. Okay, and that particular signal they have sampled at Nyquist rate. That particular signal they have sampled at Nyquist rate. Okay, so up to here, based upon after reading the first two lines, whatever the data they have given, and from there let us calculate the sampling frequency. After that let us proceed further. Okay, so here according to the given question data, they have given the maximum signal of the band limited signal, maximum signal frequency of the band limited signal as 100 Hz. 100 Hz. So here frequency is there, units are Hz. Okay, and here in this question they have mentioned that the sampling frequency is same as Nyquist rate, right? So sampling frequency is same as Nyquist rate. Okay, so can you recall what is the Nyquist frequency formula? Nyquist frequency formula. Yes, it is nothing but 2 times the maximum frequency of the message signal. 2 times maximum frequency of the message signal, right? In general, you can consider the sampling frequency. You can consider any value starting from 2 times FM, and from 2 FM you can consider any higher order value. Okay, this 2 times FM is nothing but Nyquist frequency. Okay, so just substitute FM value here. So 2 into 100, actually frequency units are Hz, but here we are mentioning sampling frequency. Can you recall the units? Of course, if you want you can represent Hz only units, but here we are mentioning sampling rate or sampling frequency. That means here you are going to get units are how many samples you are going to produce in 1 second, right? So the units I am representing here, samples per second. Samples per second, or otherwise if you want you can represent units are Hz. But in general, whenever the frequency is there, that time we will represent the units are Hz. But whenever the rate, okay, sampling rate or sampling frequency all are same. So if you want you can represent units Hz or samples per second. Okay, so whenever you use the term sampling rate, that means in 1 second how many samples you are going to produce, right? So 200 samples per second you are getting. 200 samples per second you are getting. If you want, instead of samples per second, if you want to represent, you can represent Hz also. According to your convenience you can use. But ultimately you are giving 1 by time. Time units are seconds. So per second the units is nothing but Hz. Similarly here also Hz. Okay, in 1 second how many samples that we are going to produce. Okay. Now let us further read the question. The samples are quantized into 4 message symbols that occur independently. Okay, with the probabilities they have given for the first symbol and last symbol the probability as 0.125, and whereas second and third probabilities are same, but they haven't mentioned how much probability it is. But ultimately if you observe, whatever you are getting the samples, those samples they have represented with 4 symbols, with only 4 symbols, right? So whenever you perform sum of all the probabilities, that resultant value you should get how much? Can you guess? I hope you might have studied this concept also once again in the mathematics subject in the chapter probability. Sum of all the probabilities is equal to 1, right? Sum of all the probabilities is equal to 1. Sum of all probabilities is equal to 1. According to this question, it is going to produce only 4 symbols. So that means P1 plus P2 plus P3 plus P4 is equal to 1. Now according to the given question, P1, P4 both are same. P1, P4 both are same, and that value they have mentioned 0.125. 0.125. Now regarding P2, P3, they have mentioned both are same. They have mentioned both are same. So if you want, you can consider P2 as P3 or P3 as P2. Okay, if y equal to x, you can write x equal to y. Both are same. So for the time being, I am considering P2 as P3. So P3 I am keeping as it is. P3 I am keeping as it is. Okay. So 0.125 plus 0.125. So from there you will get 0.250 you will get. 125 plus 125 you will get 250, but here you are having after the radix point, right? Then P3 plus P3 you can write as 2 times P3, that equal to 1, that equal to 1. So from here you will get 2P3 equal to 1 minus 0.25, 1 minus 0.25. So that means you are going to get 2 times P3 equal to 1 minus 0.25 is nothing but 0.75. 0.75. So from here you can write P3 equal to 0.75 divided by 2. 0.75 divided by 2. How much you are going to get? All of you can answer. It is a simple calculation. All of you give a try. 0.75 divided by 2. How much you are going to get? See, it is very simple, right? 0.23s are 6, then 15 you are having, 2 7s are 14, then 10, 2 5s are 10. So that means 0.375. 0.375. See, it is very simple. P1, P2, P3, P4. So 4 symbols you are having, and the sum of all the probabilities is equal to 1, right? So regarding P2, P3, in this question, P2, P3 probabilities are same, P1, P4 probabilities are same. Regarding P1, P4, you got 0.25. So 1 minus 0.25 is nothing but 0.75. So 0.75 divided by 2 is nothing but 0.375. So that much probability you are having for both two symbols. Symbol 2 and symbol 3 is having the equal probability, that value is 0.375. Similarly, symbol 1 and symbol 4 is having the equal probability 0.125. 0.125. So once if you are getting the probabilities, okay, you can calculate entropy. Once if you are having the probability of every symbol, with the help of that you can calculate entropy, right? So all of you just calculate the entropy. Entropy equal to summation over I equal to 1 to n probability into log 1 by probability base 2. So here first symbol probability is 0.125, 0.125 into log 1 by 0.125 base 2, log 1 by 0.125 base 2. Okay, right. Probability into log 1 by probability base 2. And here in this question, if you observe, P1, P4 both are having equal probability. So with respect to P1, okay, you got this particular term. When you have substituted P1 probability here in this expression, you got this term, right? Similarly, P4 is also having the same probability. So that means you will get once again like this term. When you are adding 2 times the same term, so instead of writing, so I am multiplying this overall term with 2. Both are same. Because here we are using the symbol sigma. Sigma stands for summation. Okay. Similarly, now let us consider P2 or P3. P2, P3 are having same probability 0.375. Okay. So for the timing, if you consider P2 with respect to that, 0.375 is the probability into log 1 by 0.375 base 2. And once again, with respect to 0.375, you will get like this 2 terms, right? So after performing addition of like these 2 terms, Okay, you can write this overall term, you can multiply with 2. You can multiply with 2, right? So just do the simplification of this overall terms. And mention your answer regarding the first term. After doing simplification, how much you are going to get. Similarly, regarding the second term, how much you are going to get. And here one more important point, whenever in the information theory concept, okay, whenever you are solving the questions related to information theory concept, wherever logarithm symbol is there, okay, so here you have to consider base value 2, base value 2. All of you give a try. What are the simplified terms or values you are going to get regarding the first term and second term? All of you quickly respond. Yes, I hope all of you are getting 0.75 for the first term. If you are not considering base value 2, then definitely you may get wrong answer, right? So please be careful while you are solving the questions regarding information theory chapter. Okay, so regarding the first term, you are going to get 0.75. Similarly, regarding the second term, after doing the simplification, you will get 1.061. 1.061. So just perform the addition. From here you will get 1.81. Okay, so 1.061. If you are making approximation, so here I am writing first term as it is 0.75. Regarding the second term, you can write 1.06. 1.06. Okay, so here 75 plus 6 is nothing but 81, and here left integer part you are having 1. So you are getting 1.81. 1.81. And here we are using the term entropy, and in general we will get the entropy units are bits per symbol. Okay, but for this question, in the symbols we are using the samples. Yes or no? Just you can observe the question. Whatever the samples you got, those samples are quantized into 4 message symbols that occur independently. That means now with the help of entropy, whatever the number of bits you got, okay, if you want, you can represent per symbol, or in other words, those symbols you are having in terms of samples, so directly you can represent bits per sample also. So here you are getting 1.81. So the units are bits per sample. Okay, now if you observe carefully, earlier we got the sampling frequency units are samples per second, and regarding the entropy we got the units are bits per sample. Now what they are asking in this question? They are asking information rate. So here you can observe the units. You are having the units in the order of bits per second. So now can you guess what operation if you perform so that you can get this overall whatever they are asking regarding the information rate? Just by observing the units only. See, you might be having so many formulas or equations in your engineering subjects, but of course definitely you have to remember few equations and few formulas, but in few contexts, even though you might be having the formula or equation, but you no need to remember that equation or formula as really formula or equation. Rather you can write the equation just by observing the units. That is the beauty of communication system subject. So in most of the cases, you can, without remembering the formulas, just by looking at the units, you can perform the operation, whether you have to perform multiplication or addition, whatever it may be. Okay, so here units are bits per second. So if you carefully observe, here you are getting samples per second, and here you are getting bits per sample. Yes, very good, Akanksha, Vashisht. Yes, very good. Yes, very good. So we have to multiply these two. Here they are asking information rate information rate. If you want, you can use the label small r, okay. So which is nothing but entropy into sampling frequency, Here entropy units are, just now we got bits per sample, and regarding sampling frequency we got the units are samples per second. So when you are multiplying these two, sample will get cancelled because it is in the numerator, it is in the denominator. Overall term you are going to get bits per second, right? So now you can substitute, this value is 1.81 into sampling frequency we got 200. So here you are having 2 zeros, and here after the radix point you are having 2 decimal digits, so both will get cancelled. So that means you are going to get directly overall one integer number, right? 2 into 181, that is nothing but 362. 362 units are bits per second. So the answer for this question is 362. Yes, very good, Akanksha. Okay, I hope it is clear for everyone regarding this particular question. Now I will show the next question, which is asked in GATE EC 2016 in the set 3 for 2 marks. All of you just give a try. Yeah, whoever tried this question, what is the answer you are getting, you can mention the chart. Okay, so meanwhile just read this question carefully. In this question they have given the bit error probability of a memoryless binary symmetric channel is 10 power minus 5. Okay, if 10 power 5 bits are sent over this channel, then they are asking the probability that not more than one bit will be in error is. Okay, that is the question. Okay, so here the error probability they have mentioned 10 power minus 5. So for the time being I am labeling the probability of error is P, that is nothing but 10 power minus 5, and the number of bits transmitted is 10 power 5. Number of bits transmitted are 10 power 5. Okay, I hope you might have studied regarding this particular concept in the mathematics subject also. Say for example, whenever you are transmitting n bits, okay, out of which in r bits you are getting error, in r bits. When you are transmitting, total number of bits are n, out of which you are getting the error in r bits, that time the probability of error, P suffix c is nothing but NCR into P power r into 1 minus P whole power n minus r. I hope you might have studied regarding this kind of format in your mathematics subject. I am transmitting, total number of bits are n, out of which I am getting the error in r bits. That time, in order to find the probability of error, this is the formula, P power r into 1 minus P whole power n minus r. Now see the question. In this question what they are asking, you have to calculate the probability of error in such a way that there should not be more than one bit error. So that means what you have to consider regarding r, what are the possible values we have to consider for according to the given data. Can you guess? Once if you are able to identify regarding r, this question is nothing, because we know the n value, we know the p value, we can substitute. Once if you are able to identify the possible values for r, all of you, can you mention what are the possible values for r according to the given question? Here in this question they are mentioning the probability that not more than one bit will be in error. That means whatever the 10 power 5 bits you have transmitted, so there is no single bit error. That means all the bits are correct. That possibility you can consider. And at max, out of those 10 power 5 bits, any one bit only you can get error. That is the meaning of this particular question, right? Not more than one bit. So according to the given question, regarding r you are having two possibilities, 0 and 1 for this question, right? So that means here P equal to n value you can substitute 10 power 5 C 0 into P is nothing but 10 power minus 5 whole power r is nothing but 0 into 1 minus P, once again same value 10 power minus 5 whole power n is nothing but 10 power 5 minus r value is 0. Similarly, you can consider like this one more term by considering r value 1. So 10 power 5 C1 into P value is 10 power minus 5 and in this case r value is 1, so power is 1. Similarly 1 minus 10 power minus 5 into 1 minus 10 power minus 5 whole power n minus r. N value is 10 power 5 minus r value is 1. Okay, I hope it is clear how I have written these two terms. Okay, whatever the equation or formula you are having, in that formula I have substituted n value as 10 power 5 and p value as 10 power minus 5, and then regarding r, in one case I have considered 0, in another case I have considered 1. Yes, very good, Akanksha. Very good. Almost correct. Okay, if you have considered, if you are almost closer. Okay, suppose if you have considered third digit also after the decimal place, then your answer will be more exact. Okay, but now also your answer is almost closer. Okay. So here NC0 is nothing but 1. NC0 is nothing but 1, and any value like x power 0 is nothing but 1. X power 0 is nothing but 1, right? Then 1 minus 10 power minus 5, 1 minus 10 power minus 5 whole power 10 power 5, plus here 10 power 5 C1, NC1 is nothing but n. So in that way you are going to get 10 power 5. This 10 power 5 C1 is nothing but 10 power 5. And here x power 1 is nothing but x. X power 1 is nothing but x. So regarding this you are going to get 10 power minus 5. Now 1 minus 10 power minus 5. So here you are having 10 power 5 minus 1. I am keeping as it is. Now if you carefully observe 10 power 5 into 10 power minus 5. This overall term you are going to get 1. You are going to get 1. Now just observe, here also you are getting 1, and then you are having 1 minus 10 power minus 5 whole power 10 power 5. This overall term also 1. Okay. Once again here if you closely observe, you are getting similar term. Here power 10 power 5, here also power 10 power 5 but minus 1. So 10 power 5 when compared to 1 it is very large. Okay. If you want, while you are doing the simplification, you can consider exactly like 10 power 5 minus 1. But if you want to make approximation, you can just consider 10 power 5 minus 1 is nothing but 10 power 5. So that means whatever this value you are going to get, same value you are going to get here also. Okay, right. So after solving this one, regarding the first term, you will get 0.368. Regarding the first term, you will get 0.368. Similarly, second term also you will get 0.368. Okay, when you are adding both, 8 plus 8 is 16, then 1 plus 6, 7, plus 6, 13, plus 1 plus 3, 4, plus 3, 7. So you are getting 0.736. Okay, right. 0.736 you are getting. Suppose if you are rounding off to the 2 decimal places, then you will get the answer as 0.74 because the third digit value is greater than or equal to 5. Okay, so you are getting 0.74, 0.73 or 0.74, no problem, because whenever you are getting NIT questions, especially when you are getting answer as the fractional part or real number, definitely they will give the range of numbers. Okay, whenever you are getting exact integer like 5, obviously you have to enter 5, but whenever you are getting NIT questions, they will provide the range of values. Whatever the answer you are getting, if your answer falls in that particular range, definitely they will consider as the correct. That's why I have told you whatever the answer you have mentioned, that is almost closer, right? That is also correct. 0.73 also you can consider. But if you are getting exactly like 0.735, right? Yes, you are getting 0.735. Here I am getting 0.736, almost same. When you have round off to the 2 decimal places, then you can get the answer as 0.74. 0.74. Okay. So in this way, we have discussed in this particular session variety of GATE questions which are asked in the year 2016. Now we are having one more question, but in this question I am not going to discuss this question, but I am giving this question as a homework for all of you. So all of you kindly solve this question in your free time. This is a homework question. So all of you take the screenshot of this question and you can give it a try. Okay. Regarding this question, in tomorrow's session, okay, in tomorrow we are going to start the session at 3 o'clock as usual. So in that particular session, I will discuss this question at the beginning. After that, we'll discuss the selected questions which are asked in the year 2015, right? So all of you take the screenshot of this question and you can try, and whatever the answer you are getting, you can mention in the comment section, right? So you are having the time till tomorrow 3 o'clock, right? Okay, so till then you are having the time. So this is the question wise. When you look at the question, it seems to be lengthy, but this is the logical question, and this question based on the probability concept. So whatever the formula earlier question we have used, similar formula you can use for solving this question also. This is a very interesting question and logical question. That's why I have kept this question as a homework question, right? So instead of discussing this question in this session, I am keeping the suspense for all of you, and in fact you will get the good comment over the concept or subject. In order to get like that, I have given this question as a homework, right? Yeah, thank you, Akanksha. I have seen your comments in the earlier session. Okay, so I hope you are watching my sessions either in the live or recorded format. So I am very happy to see you in the live session. Okay, so kindly share this playlist with all of your friends so that whoever preparing for the coming GATE exam, they also will get benefited by watching this series of lectures, right? So we'll meet you all in the next session, that is on tomorrow. Thank you, everyone.